Hi, in this video we will discuss the Hooke's law and later we will see how to solve when springs are connected in series or in parallel. So let's begin with the spring force. As we know, a spring is a helically shaped wire which gets compressed or elongated when a force is acted axially. And when the force is released, it returns to its original shape. And there are many other kinds of springs like leaf springs, torsional springs, etc. But now we will just discuss the general case of springs. So let's consider a spring which has a natural length of L. So when a force F is acted on it in the opposite direction, the spring will elongate and it will have a new length L1. And when a compressive force Fc is acted on it, then it will get compressed to a length L2. As we can see, L1 is greater than L, which is greater than L2. So the elongation of the spring due to the force F is E1 is equals to L1 minus L. And the compression of the spring due to the force Fc is E2 equal to L minus L2. And according to the Hooke's law, for a spring, the axial force applied is proportional to the change in length of the spring. So we can say F is proportional to E1 and Fc is proportional to E2. Now we can replace the proportionality by a constant K, which is called as spring constant, and its unit is Newton per meter. And this constant value is different for different springs. Its value depends on the material of the spring, length, and other dimensions of the spring. And this relation is called as Hooke's law. If we plot the force versus the extension of the spring, it will be a straight line passing through origin with a slope k. Consider a mass m connected to a spring of spring constant k and natural length L. Now when the mass is released, the spring will expand to a new length L plus E. So as we have discussed earlier, E is equals to F by k. And here the force is due to the weight of the mass m. Here you should note a point that the tension in the spring will be same at every point, which is equals to mg when the spring mass is neglected. Now let's consider a situation where two similar springs are connected in series supporting a mass m. Here the total elongation will be equal to the sum of the elongations of both springs, and we can use the Hooke's law. As the tension will be same in both springs, that is F1 is equals to F2 equal to mg. So the total elongation will be equal to 2mg by k. Now let's take an equivalent spring which has the same kind of properties as the two springs in series. So if k dash is the spring constant of the equivalent spring, then we can write the elongation of this spring as mg by k dash. And since it has equal properties as the two springs in series, their elongations are also equal. So we can get k dash is equals to k by 2. Similarly, if n equal springs are connected in series, then equivalent spring constant k dash is equals to k by n. But what happens when n different springs are connected in series supporting a mass m? Then the total elongation will be equal to the sum of elongations of all the springs in series. Now we can replace these n springs by an equivalent spring of spring constant k dash. So its elongation is E dash is equals to mg by k dash. Since both systems are equivalent, their elongations will be equal. So we get 1 by k dash is equals to 1 by k1 plus 1 by k2 plus 1 by k3 plus and so on 1 by kn. Now I have a question for you. Consider a spring with spring constant k and a natural length L. Now if it is cut into a new length L1, then what will be the new spring constant? Stiffness of a spring increases when its length is reduced. Thus, k is inversely proportional to its length. Since the material and other dimensions are similar, we can relate the spring constant with their lengths as k1 by k is equals to L by L1, and thus k1 is equals to k into L by L1. So note that this relation is used to compare two springs with similar properties except length. And now there is another approach to these kind of problems. Let's say the length of the spring is cut to 1 by 4th of its original length. So in order to find the spring constant of this 1 by 4th length of the spring, we can resemble the original spring by 4 equal springs each of length L by 4 connected in series. And thus k is the equivalent of 4 springs in series, which means spring constant of 1 by 4th spring is 4 times the spring constant of original spring. Thus k dash is equals to 4k. And similarly, if we take half of the length of the spring, then its spring constant will be 2k. And similarly, for 1 by nth part of the spring, k1 by n is equals to nk. So these relations will be useful while solving problems. I hope you got the concept. If you have any doubts, please comment down below. Please subscribe for more videos and like the video. Thank you.